So hi all, right now we are going to discuss one algorithm which is already known and familiar to you, that is MergeSort. So you have solved a MergeSort and learned the MergeSort algorithm in the second year itself in the data structures course. So here we'll be learning with learning again, and we're doing time complexity analysis. Okay, we'll start. So actually to do MergeSort, we'll be having a list of n elements, and the list of n elements will be written in this way: a of 1 to a of n. So it's a sequence of n elements, and to do MergeSort, generally what we do is we'll divide the set of elements into two subparts. Okay, suppose if we have four elements, we'll divide them into two: 1 3 as one sublist and 4 8 as some other sublist. If I have five elements, so this is first element, second element, third element, fourth element and fifth element, you will be dividing at the middle. So how you will get the middle? In most of our sorting algorithms, we'll be calling the first index as the lower bound or low, and the last one as upper bound or high. Okay, so you can calculate the midpoint by using the formula low plus high by 2. So 1 plus 5 by 2 is 6, 6 by 2 3, at 3 you can cut 1 3 4 1 will be one problem, and 8 7 will be another problem. Suppose if you take half, and that half is by mistake, if the half is 3.5, you will consider its floor value, that is 3. So when you divide by 2 and you get a fraction, you'll discard the fraction and you'll see that you'll consider only the integer part. In that way, we'll divide the entire list into two lists. The midpoint is n by 2 from the first element to the midpoint, and the next element from the midpoint to the end is the another list. So that's the reason we'll be split into two sets: a of 1 to a of n by 2. And what is the next element of n by 2? A of n by 2 plus 1 to a of n. These two are the two sublists we are going to use in MergeSort. After dividing them into sublist, we'll again apply MergeSort on the first sublist and second sublist. We'll go on dividing the list, apply MergeSort. After sorting, we have to merge the sorted sequences into a final sorted sequence. So MergeSort can be written in this way. We'll split the set into two equal size set, and we'll combine the sorted things by merging operation. So MergeSort algorithm is combination of two shorter algorithms. One is MergeSort algorithm, other one is merge algorithm. MergeSort algorithm generally tells you that you have to divide it into two parts, apply MergeSort again. So the recursive call will be present in the MergeSort algorithm. And after solving the sub problems, you will be having two sorted sublists, no? Like this. This is one sorted and this is another sorted sublist. You have to combine these two to get the final list. This kind of operation you will do in one more supporting algorithm called merge. So to learn MergeSort and to write algorithm for MergeSort, we have to write MergeSort algorithm and merge algorithm. So before writing the algorithm, we'll take a set of elements and we'll apply MergeSort and merge algorithms on top of it, and then we'll write the MergeSort algorithm. Okay, so let us take a set of 10 elements. As we have taken set of 10 elements, here n equals to 10. Okay, so n is 10 means the first index, the low is 1 and the upper is 10. So 1 plus 10 by 2 is 5.5. So we'll be taking fifth location as the midpoint. So we'll be dividing this into two subparts, and the first subpart need to be solved first, and again second subpart need to be solved next. After sorting the first one and sorting the next one, then we'll apply merge operation to get the answer for the final one. See the tracing. So this is your set of 10 elements. These are your set of 10 elements and they are divided at the middle. So this is the first sub-problem, this is the first sub-problem and this is the second sub-problem. Okay. So the first sub-problem is solved. As we have more than one element here, we further need to split the problem into sub-problems. So here the indices are 1, 2, 3, 4, 5 and here 5, it starts, next list starts from 5 plus 1, 6, 7, 8 up to 10. So what is the midpoint here? 1 plus 5 by 2, that is 3. So we'll be splitting at this part. So this is one more sub-problem, this is another sub-problem. Coming to here, it is also more number of elements, more than one element. So we need to further split it. Index is 1, 3. So 1 plus 3 by 2 is 4 by 2 is 2. So we'll be splitting here. So this is 1 and this is 1. Check out the first sub-problem. Here you have two elements, that means more than one element. So you have to split it into two equal halves again. So they are divided into this way. So now there is no further requirement of division. So we'll stop dividing the problem into sub-problems. If you observe these two, can I call these as two sorted sublist? Yes, they are sorted sublist. 310 is one sorted sublist, 285 is another sorted sublist. Now we need to apply merge operation to merge these two sorted lists into another sorted list. Okay. So what is merge operation? First I'll understand it on the blackboard and then we'll come back to the tracing. Okay. So what is merge operation means? To do merge operation, first you should have two sorted lists. Consider that this is a sorted list and this is one more sorted list. Okay. So you can merge these two sorted lists and you will get 6 elements here, because in the first list you have 3 and the second list you have 3. You can have more also, it's not an issue. You can even have more in one list, smaller in another list also. So what is the merge operation? What is the logic behind merge operation is, we'll start at the beginning of the first list and we'll start at the beginning of the second list. Okay. Let us assume that beginning of the second list is j and beginning of the first list is I. Okay. This ith element and this jth element will be compared. Which is minimum among 2 and 12? Obviously 2. So this 2 will be stored in a new list. As it is stored in a new list, this j will be moved to 8 now. Now 8 and 12 gets compared. So which is minimum? 8. So 8 will be stored in the new list and this will be moved here. Now 12 and 11 are compared. As 11 is minimum, 11 is moved and it will come here. And j comes there. Now 12 and 18 gets compared, which is minimum 12. So 12 will be moved here. So after moving 12, now I becomes 13. So ith element and the jth element are compared, 13 and 18, which is minimum 13. So that will be placed here. So after placing I comes here. Next I and j are again compared, 25th and 18. So 18. So j reached end of the file, end of its list. Okay. So when some pointer, either I or j, reaches end of the list, then what we can do is, whatever is remaining in the other list, that you can copy as it is here. So this is the logic for merge operation. To merge two lists, you will assume two pointers, you will compare the elements, whichever is minimum, you will put it in a new list, and whatever is put in the new list, that pointer will be moved. So this process will be continued until you complete one list. After completion of one list, whatever is left in the second list, that will be pasted at the end of the answer. So this is the sorted list, sorted set after merging two sorted sets. So this is called as merge operation. So we'll go back to our tracing. here I have one list with 310, another list with 285. So 310 and 285 are compared, as 285 is minimum, that has come here. We reached end of this list, so 310 will be pasted at the end. So this is answer for this problem. This is answer for this problem. Next, after solving this subproblem, we'll go on to the next subproblem, that is 179. We have only one element, so there is no need to further split. You can combine the answer of this and the answer of this into a new list. So the answer of this is this guy and this is this. 285 and 179 are compared. As 179 is minimum, we put here. We reached end of the list. So whatever is left in this list is pasted here. So this 179, 285, 310 is answer of this subproblem. Okay. After solving this, we will be going on to solving this one. 652 and 351. Okay. This, as they are more than one element, we will be splitting it into two equal halves. So 1, 1. This is one sorted list. This is another sorted list. We will be merging it. 652 is compared with 351. 350 is minimum. Put here next 652. This is answer for this problem. This is solved and this is also solved. The answers are here. We will merge these two to get the answer for this guy. So merging. 179 is compared with 351. 179 is minimum. We have come here. 285 is compared with 351. 255 is minimum. 310 is compared with 351. 310 is minimum. We reached end of the first list. So whatever is left in the second list will be placed at the end of the answer. This is answer for this guy. Okay. After solving this problem, we have to start solving the second subproblem, second half of this. So here the lower boundary is 6, upper boundary is 10. 6 plus 10 is 16. 16 by 2, 8. At the 8th location you will be splitting. We'll apply the same process in splitting and apply the same process in merging. This is the answer for this guy. Okay. So we have answers for first subproblem, answer for second subproblem. We'll apply the merge algorithm to get the answer for the main problem. So this is tracing. When you are given with a set of numbers, you need to follow this neat, clean procedure to trace the set of numbers. Okay. Dividing the problem further into subproblems will be done as part of the MergeSort algorithm. The answers will be combined with the help of a smallest algorithm called merge algorithm. So this is tracing. So shall we translate our understanding into an algorithm now? First we will write the MergeSort algorithm and next we will write the merge algorithm. So MergeSort algorithm is this one, very simple and easy to remember. So MergeSort algorithm will be written in this with two arguments. You will be having set of numbers, no? You will be having set of numbers. So sometimes we need to sort only this part. Sometimes we need to sort only this part. We don't know. It's not always we are sorting the entire list. Sometimes we have to sort part of the list. So for that reason, we will be passing boundaries. What is the index of this? What is the index of this? From this to this only, please sort. In that way, we will be passing only boundaries. That's the reason the arguments are low, high. Okay. So, for example, this understanding you should have for all kinds of problem. Suppose if I have 4 elements, the low is 1 and the high is 4. When low is less than high, when low is less than high, you have more number of elements in your problem. Okay. If you have only one element, if you have only one element, low and high both are same, right? So when low equals to high, you have only one element in the list. When low is less than high, you have more elements in the list. When low equals to high, one element. Whenever while solving the algorithm, low crosses high, low value exceeds high, then there are no elements to do anything. That's the reason in many algorithms we have this condition. Okay, whenever low crosses high, we'll stop the process because there are no elements to do anything. Okay, so you will be passing the lower boundary and upper boundary of the list to which you want to do sorting. First you will check the base condition. Are the elements present or not? Okay, when the elements will be present? If low equals to high, one element only, no need to split. So whenever low is less than high, then only we have more than one element. So we will be checking one condition whether we have more than one element or not. Okay, if we have more than one element, we are going inside and calculating the middle part. Low plus high by 2 is the middle part. After calculating the middle part, we are asking this guy, please sort the first half. After sorting the first half, sort the next half. So what is the first half? If my lower boundary is 1, upper boundary is 10, what is the mid value? 5. So first half is from 1 to 5, second half is from 6 to 10, right? So first half lower boundary is 1, upper boundary is 5. Second half lower boundary is 6, that is nothing but mid plus 1, right? So sort the first half, that is low comma mid. Next sort the second half, that is mid plus 1 comma high. After sorting both the sublist, we are asking merge algorithm to combine the answers. So how we have to call the merge algorithm? Suppose I have 5 elements. I divided this into 2 equal halves and I asked MergeSort to merge it. I asked MergeSort to sort it. So uh, they are already in sorted out. Let it be 8. 8, 10, 11 and this is 4, 12. Okay. So these are sorted sublist. And these two we have to pass to the merge algorithm. This is first list. This is second list. Even though I am treating it as two lists, they are present in a single array, right? So what should I do? I have to pass the index of this, index of this, index of this and index of this to my merge algorithm. Hey, first list starts from 1 to 3, second list is from 4 to 5. In that way I have to pass. So what is the first list? Where first list is starting? At low. Where the first list is ending? At the mid location. When I know where the first list is ending, do I need to give the index of the second starting? No. The very next location, no. So we are not sending the starting of the second list. We are just sending the ending of the second list. Okay. So for this, we'll be calling in this way. Merge 1, 3, 5. Merge 1, 3, 5. Okay. So first list opening and ending and second list ending. Second list opening is anyways mid plus 1. So in that way I am sending both the sorted list to an algorithm called merge where it will merge the things. Okay. So if you have more than one element, calculate the mid, sort the first half, sort the second half, merge the first half and the second half by passing the boundaries. We are not passing the starting of the second list as it anyway starts from the mid plus 1. So that's the MergeSort algorithm. Now merge algorithm. Okay. So merge algorithm is again very simple. So in merge algorithm you will be having two lists. So this is the first list and this is the second list. I will start in the first list from here and I also started the second list. Okay. I am passing low, mid, high. What is the beginning of the first list? Low. What is the beginning of the second list? Mid plus 1. Right? So that I am storing here. Starting of the first list, starting of the second list. Okay? And after combining, I have to put it in a new list now. So new list is empty now. Let it be H now. Okay. So if this is the first list, the same thing I have to put. That's the reason H equals to low. In that way, I have to set 3 pointers. Starting of the first list, starting of the second list, and starting location of the array where I have to store my answers. Oh, okay. Next I am checking this. So I am checking whether I have reached the end of the list or not. If I reach the end of this list or if I reach the end of this list, then I will stop. So how to find out whether I reached the end of this list or not? End of this list is mid, end of this list is high, right? If I reaches mid or J, J reaches high, then we will stop. Okay. So what I will be doing is, oh, we put I here, sorry, and I here. So we will be checking uh, H element with J element. A of H, A of J, who is smaller? If A of H is smaller, we will put the A of H in the ith location of the second array and we will increment the H. Okay. If jth element is smaller, we will keep the jth element in the second array and we will increment the J. So that is happening here. Whichever element is smaller, that will be put inside the answer array and that index will be incremented. Okay. So when one of the list gets exhausted, the other list as it is will be dumped onto the answer. So we have to check which list is ended. If H is less than mid, that means if this list is not ended, then we'll put these things into this answer. That is done here. If this list is not ended, we'll put the answer here. In that way, we will compare number by number and keep the answers in the temporary array. After keeping all the elements into the temporary array B, we'll keep the answers again into the original array A. So this is the merge algorithm. Both of these will give you the MergeSort algorithm. Both of these will give you the MergeSort algorithm.